Okay, so get this, right? We're living in a world where computer programs are writing news articles.
Yeah.
Like spitting out code like a seasoned developer, even composing music that
Really?
wouldn't sound out of place on your favorite playlist.
It's pretty amazing.
It is pretty amazing. And I'm talking about LLMs. And chances are, I think you've probably already interacted with one without even realizing it.
That's right.
But what are these things, really?
Well, that's the thing about LLMs, or large language models. They're kind of like super-powered language whizzes, you know?
Yeah.
Imagine a computer program that's been fed like
What?
a massive amount of text data.
Like how much are we talking?
Seriously, like a significant chunk of the internet.
A significant chunk of the internet. So we're talking like every blog post,
Yeah.
every social media rant, every online encyclopedia entry.
Pretty much.
Yeah.
And by processing all this information, these LLMs, they start to
What?
pick up on patterns in language, like grammar and style, even facts about the world. And then they use those patterns to predict what word comes next in a sequence.
Okay, so is it just a glorified version of like autocomplete, because my phone can predict the next word I'm going to type, and it's not exactly writing symphonies.
Right. It's way more complex than that.
Okay.
Think of it this way.
How?
These models have billions of parameters, almost like tiny little knobs that get adjusted during training.
Yeah.
And this complexity is what allows them to create text that isn't just grammatically correct, but also feels coherent, relevant, and even creative.
Right. So it's wild. It's really wild.
It's really wild.
Okay, so my mind is already a bit blown, but
yeah.
you mentioned tokens earlier, and I wanted to ask you about that.
Yeah.
What exactly are those in the context of LLMs? It sounds a bit like something you find in a board game.
It kind of is, yeah. That's a good way to think about it. A token is essentially the basic unit of language that these LLMs work with. It could be a whole word, like cat, or part of a word, like ing.
Okay, so why not just stick with whole words all the time?
Yeah.
It seems simpler, right?
Well, if only languages were that straightforward. Think about all the different forms of the word run, like running, ran, runs.
Yeah.
Subword tokenization. It allows the model to handle all these variations and even deal with words it's never seen before.
Okay.
It's kind of like having a set of Legos. You can combine them in countless ways to build just about anything.
Wait, so you're saying the LLM, it doesn't see words the way we do. It's working with these Lego-like tokens instead.
Right. Exactly.
That's kind of blowing my mind right now.
I know, right?
It is.
So now each of these tokens is then converted into a numerical representation called an embedding.
Embedding, okay.
Yeah, so imagine a vast multidimensional map.
Okay.
Where words with similar meanings are clustered together.
So the embedding is like giving each word like a set of coordinates on this meaning map.
Exactly. Cat and kitten would be like snuggled up close together, while cat and airplane would be like miles apart.
Okay.
This allows the LLM to understand relationships between words.
Even
if it hasn't seen those specific words used together before.
Okay, so it's not just memorizing definitions. It's actually understanding the connections between concepts.
Right.
That's incredibly powerful.
Very powerful.
So we have these tokens, right? We have their embeddings. What about the model's vocabulary? Is that like its own personal dictionary?
You're right on track there.
Okay.
Think of the vocabulary as the LLM's dictionary, but instead of definitions, it contains those numerical embeddings for all the tokens it knows. And the size of that vocabulary can vary wildly.
Okay, how so?
A larger vocabulary, it means the model can handle a wider range of words and ideas.
Okay.
But also makes the model itself more complex.
So it's a trade-off.
Exactly.
Bigger vocabulary means more potential, but also more computational muscle required.
Exactly.
This is all starting to make sense.
No.
But I have to ask, you mentioned LLMs are auto-regressive earlier.
Yeah.
What does that even mean?
Well, auto-regressive just means that the model generates text one token at a time.
Okay.
With each new token based on the ones that came before it.
Okay.
It's a bit like when you're writing.
Yeah.
You choose each word based on what you've already written.
Okay, so it's not like it's magically spitting out like a whole paragraph at once. It's carefully constructing it, like brick by brick.
That's it.
Or token by token, I guess.
Token by token, yeah.
Okay.
It predicts the next token, adds it to the sequence, and then predicts the next one, and so on. But the step-by-step approach, it makes it a real challenge to generate long pieces of text that are both coherent and meaningful.
It's kind of like, what's that, building a house of cards? One wrong move, the whole thing collapses.
Exactly.
Okay.
Yeah.
Wow, so I'm starting to see just how much is going on under the hood of these LLMs.
Mm-hmm.
So we have this huge language model trained on like a mind-boggling amount of data.
Right.
It breaks down language into these like Lego-like tokens.
Yeah.
Represents them as embeddings on this giant map of meaning, uses its vocabulary and this auto-regressive way of working to generate new text. Am I getting it so far?
You got it. You've grasped the fundamental building blocks here.
Okay.
Now, to truly understand how these LLMs are able to write articles, compose music, and do all these other amazing things, we need to look at the engine that makes it all possible.
Are you talking about the architecture of these models?
Yes.
Because I'm definitely ready to crack open the hood and see what makes them tick.
You read my mind, and trust me, what we're about to dive into is truly revolutionary.
Okay.
Get ready for the world of transformers.
Transformers?
Yeah.
Like robots in disguise?
Not quite.
Okay.
But their impact on language processing has been just as transformative.
Yeah.
This architecture changed the game for natural language processing.
So
We'll get into the nitty-gritty.
Hold on. We're not taking a break.
Okay.
You've got me hooked. Spill the beans. What's so special about these transformers? All right, spill the beans. What makes these transformers so special? They sound pretty intense.
Well, before transformers came along, most language models relied on something called recurrent neural networks.
Like what, RNNs?
RNNs, for short, yeah.
Yeah, and those were less efficient.
Exactly. They process text one word at a time, which could be pretty slow, and they weren't great at handling those, long-range dependencies in language.
What do you mean by that?
Like how words at the beginning of a sentence can relate to words much further down the line.
So like remembering the subject of a sentence by the time you get to the verb?
Precisely. But then transformers swooped in with this amazing thing called self-attention.
Self-attention?
And it was a total game changer.
How so?
Imagine you're reading a sentence with self-attention. Every single word can actually look at all the other words and figure out which ones are most important for understanding its meaning.
So each word is basically analyzing its relationship to all the other words in the sentence at the same time.
Yeah, it is. And because of that, transformers they're able to grasp the context of each word much better than those old RNNs.
Okay.
Plus, they can do all of this in parallel,
Right.
Processing multiple words at the same time.
So it's like they have a superpower that lets them see the whole picture instantly.
You got it.
No wonder they're so much faster, more accurate.
Exactly. The transformer architecture is what really allowed us to build those super large and powerful LLMs that are doing all these incredible things today.
Okay, transformers, self-attention. I'm starting to get the picture.
Yeah.
But what about those parameters we talked about earlier?
Yeah.
Those tiny little knobs that get adjusted during training?
Yeah.
How do they fit into all of this?
Well, those parameters they're the key to the whole learning process.
Okay.
Think of them like the settings on a sound mixer.
Okay.
They control how all the different parts of the model connect and communicate with each other.
So by adjusting those parameters, we're essentially shaping how the model interprets and generates language, like fine-tuning an instrument to get just the right sound.
Yeah, exactly. During training, the model is fed, massive amounts of text data, and the parameters are constantly being adjusted to minimize errors and help the model get better at its tasks.
So the more parameters, the more nuanced and sophisticated the model's understanding of language becomes.
Generally speaking, yes.
Okay.
Larger models with more parameters tend to be more capable.
Okay.
But it's not just about the sheer quantity of parameters.
Yeah.
It's also about how well they're trained and the quality of the data that's used.
Makes sense. So you could have a model with billions of parameters, but if you train it on bad data, it's still going to produce garbage.
You got it. The data is the fuel that powers these models. And if the fuel is contaminated, the engine won't run smoothly.
So how does this training process actually work? How do you teach a model with billions of parameters to understand and generate human language? It sounds like trying to teach a dog to do your taxes.
It's definitely a complex process,
Yeah.
but it all comes down to feeding the model tons of data and letting it learn through trial and error. We use a technique called backpropagation to help it along.
Backpropagation. Okay, another one for the glossary.
It's basically a way for the model to learn from its mistakes.
Okay.
It looks at the errors it makes and then adjusts those billions of parameters ever so slightly to improve its performance on the next try.
So it's constantly analyzing its own output, finding ways to get better, and tweaking those parameters. It's like having a built-in self-improvement coach.
Exactly. And this training process can take days, weeks, or even months,
Wow.
depending on the size of the model and the amount of computing power you have available.
So it's a marathon, not a sprint.
It is a marathon.
That's insane. So much computational power, so much data, all going into creating these LLMs.
It is.
But all of this effort has to be leading to some pretty incredible results, right?
Absolutely. The advancements in LLMs they're happening so fast, it's almost hard to keep up.
Yeah.
We're seeing breakthroughs in natural language understanding, machine translation, text summarization, even things like question answering. It's truly mind-blowing.
It really does feel like we've unlocked this whole new level of language processing that was just a fantasy a few years ago.
Yeah.
You know,
Right.
It's amazing. But I have to ask, are there any downsides to this?
That's a great question and a perfect segue into our next topic.
Okay.
Like any powerful tool, LLMs have the potential to be misused.
Yeah.
And there are a lot of important ethical questions we need to consider as this technology continues to evolve.
That makes sense. It's like that old saying, with great power
Yeah,
comes great responsibility.
exactly.
I'm definitely curious to explore that side of things. So
Yeah.
we've talked about all the amazing things LLMs can do, but let's get real for a second.
Yeah.
What about like the potential downsides?
Yeah.
What kind of responsibility comes with wielding this much power over language?
Well, you hit the nail on the head there.
Yeah.
LLMs, they're incredibly powerful tools. And like any tool,
Yeah.
they can be used for good or for bad.
Yeah.
You know, it's like fire. It can keep you warm and cook your food,
Right.
but it can also burn down your house if you're not careful.
So no more roasting marshmallows over an open LLM.
Right.
Got it.
Exactly.
But seriously, what are some concrete examples of how these models could be misused?
Well, one concern is the potential for, spreading misinformation.
Okay.
Imagine someone using an LLM to generate fake news articles or social media posts that are so convincing people can't tell the difference between what's real and what's fabricated.
Yeah, that's scary.
Yeah.
I mean, we've already seen how easily misinformation can spread online, but with these LLMs, it can become even more sophisticated and harder to detect.
Exactly. And it's not just about fake news.
What else?
Think about spam, phishing scams, even propaganda. All of these things could be amplified by LLMs in the wrong hands.
So it's like giving bad actors a super weapon for manipulating people and sowing chaos.
It is.
That's a pretty bleak thought. Is there anything we can do about it? Is there any way to prevent this kind of misuse?
It's definitely a challenge, but I believe we can address it.
Okay.
One important step is to develop safeguards and detection mechanisms that can help us identify when content has been, generated by an LLM.
So kind of like a digital fingerprint that tells us, hey, this text didn't come from a human brain, it came from an algorithm.
That's the idea, and researchers they're already working on this.
Right.
They're looking for subtle patterns and tells that can distinguish between human-generated text and LLM-generated text.
That's reassuring.
Yeah.
But even if we can detect fake content, isn't there still the risk that people will believe it anyway? I mean, people believe some pretty crazy things already.
That's true, and that's where, education and media literacy come in.
Okay.
We need to help people develop, the critical thinking skills they need to evaluate information online,
Right.
regardless of where it comes from.
So it's not just about fighting the technology.
Right.
It's about empowering people to be more discerning consumers of information.
Exactly. It's about giving people the tools they need to navigate the digital world safely and responsibly.
That makes a lot of sense. It's like we wouldn't give someone a chainsaw without teaching them how to use it safely, right?
Precisely. LLMs are powerful tools,
Mhm.
and we need to treat them with the same level of care and responsibility.
Well, this has been an incredible deep dive.
It has.
We've gone from the basics of tokens and embeddings to the mind-blowing world of transformers, and even explored some of the ethical challenges that come with this powerful technology.
Yeah, it's been a fascinating journey, and it's just the beginning.
Yeah.
LLMs are constantly evolving, and
Right.
we're only scratching the surface of what they can do.
And as they continue to evolve, it's up to all of us to ensure that they're used for good. Thanks for joining us on this deep dive into the world of LLMs. We hope you learned something new and maybe even had your mind blown a few times along the way.
Until next time, keep exploring, keep learning, and keep those neurons firing.